So we've created our APR chart for our average speed function that we want to write. Now let's write the actual Python code. I have an idle window open here. And remember that at the top, you'd always include your header comments. And then you would import any non-standard libraries. I don't think we're going to need any, so I'm not going to include any in my code. The next thing I'm going to include are my definitions for functions. So I want to define a function to calculate the average speed. I'm using the def reserved word, and then I chose the name average speed for my function. Or maybe I'll make it calculate average speed. Cool. And then I want to include my parameters. I need those to match up with the expected arguments. So I know I'm going to need information about the distance traveled and the amount of time required for the trip. I don't know what information is actually going to be included in there, so I need placeholder names, parameters, when I'm writing the function. So I'm going to call them distance traveled, and I'm going to call the second parameter time. Then I have my colon, and then it will automatically start indenting my code. For my processing step, I want to make the calculation for the speed. So the speed is equal to the distance traveled divided by the time required. And that was my only step I needed for this particular algorithm. Often your function definition will require multiple steps, but this one just includes one. And then finally, I want to return my value that I calculated. In this case, I calculated the speed. And as soon as I have the return statement in there, Python knows I'm done writing the function definition, and so it automatically brought me back out here to the regular margin where I would start executing the code. Now think through, do you think that just writing this definition on its own does anything if we would execute it? You can try it out. If you typed along in Python, you can try to run the module, see if anything happens. And if you run it, you'll see that nothing happens. It just runs the program and it looks like nothing went on. And that's what happened, because just writing the function doesn't actually launch it into action. It just creates the potential. Just like the functions that are in the standard library create the potential for us to do useful work with those functions, just having them in the library doesn't make them leap into action in our code. We have to actually call them in our code in order to make the function useful and have it perform work. So our next step in our Python code writing adventure is going to be to add the main code piece that allows us to execute the function. We're going to put that below the function definition right here. This will be where the main algorithm goes. Remember that our main program has to do some fact finding, has to get some information from the user about how far they want to travel and how quickly they're traveling, so that we're able to pass that information into our function. The main program should activate the function and pass in the required information. And then the main program needs to store the result that comes back from the function so that it can then print it out. So we're going to create an IPO chart for the main program's actions. I already listed all of the processing steps in there. We just outlined those, where we have to ask the user to enter the distance traveled and also the time traveled. Both of those pieces of information are going to be the input. And then we need to call the function to calculate the average speed and store the result. And then finally, we want to print out the average speed that was calculated. So our IPO chart would be similar to the one for the function itself, because we're using related information. In this case, the input is going to be the arguments to the function, and the output is going to be the return value that comes back from the function. Let's go ahead and turn that into Python code. Remember that the main program instructions go at the bottom of our program. And so our program might look like this. I typed everything out for you. When I wrote the example in the notes, I used slightly different variable names. The one that's in the notes works well, and the one that I'm going to write on the screen is going to work well as well. Just realize that you can use any names you want when you're writing your variables. So our main program, remember, it's going to require us to get two pieces of information, a distance, which we're going to get as a floating point piece of information so that we can have fractional miles if we want to. And then we also have to get the amount of time required for the travel. I'm going to call it time required here. And then I want to call my function that's going to make this algorithm leap into action. And so my function call, because it returns a value, I have to say something like result equals, and then give the name of the function, calculate average speed. And then I need to pass in the two pieces of information that will match up with these placeholder parameters. The actual data values we want to operate on are distance and time required. I have to use the names of the variables that are part of my main program. And then finally, I wanted to display the results. So I'm going to include a label. The result is, and then print out the result, the information that comes back from the function. At this point, I should be ready to run the program. Let's run it once just to see how it's working. So if I enter the distance traveled in miles, let's say I go 30 miles, and that it takes me, I don't know, 5 hours. Oops, spelled something wrong. Time required. All right, let's try it again. So if I go 30 miles and it takes me 5 hours, that means that I traveled 6 miles per hour. I should probably put a units in there so that it's more clear. Miles per hour. What that 6 represents. Oops, I got an extra parenthesis. All right, one more time. Third time's the charm. So if I type in, it was 30 miles, it took 5 hours. It's telling me it's 6 miles per hour. Cool. So to summarize, if you want to create your own function, you have to create your function code at the top of the file. That was like where we defined our calculate average speed function. Then we have to write our main program at the bottom of the file. That has to include a call to the function, anywhere you want those instructions to execute. You have to pass in the arguments that are required for the function, and they have to match the expected order of the parameters, because Python just matches them up in order. So it takes whatever the first argument is and matches that with the first parameter. They have to logically represent the same information. And then the second parameter or second argument will get matched up with the second parameter. Again, they have to logically represent the same thing. If the function's expecting distance first and time second, you can't call it with the time first and the distance second and expect it to carry out the instructions correctly. And then finally, if there's a return value, make sure you save it somewhere in your program so that you're able to print it or otherwise use that result in your code. The rest of the notes for today have some example exercises for you to try out all of the ideas we've been talking about creating APR charts and writing functions and creating function calls. So definitely check those out and see if you can solve the try it out problems.